Mr. Bridenstine, it's great to see you here today. It was certainly a pleasure to work with you in your previous capacity as a NASA administrator. And as you're well aware, in 2020, the President signed the Pro-SWIFT Act into law. I authored this bipartisan legislation to strengthen the nation's ability to predict severe space weather events and mitigate the harmful events. And I appreciate you championing that with me. You were very helpful in getting that bill across the finish line, so thank you. As you know, a space weather event can have implications for power systems, for GPS, other assets in low Earth orbit. And on Monday, the National Weather Service Space Weather Prediction Center actually just recently issued a watch for a potential geomagnetic storm, as you're aware. Continued research is needed to strengthen our space weather prediction capabilities to ensure that we can have these accurate warnings. Unfortunately, the President's budget includes cuts to this funding that could jeopardize these efforts and could have major implications for those communication systems in particular. So my question for you, sir, is could you speak to how NASA's science missions, like the Space Weather Program, play a critical role in our everyday lives? This is non-political, this is straightforward. Why do we need to make sure funding for space weather prediction?
There's a lot of different reasons to do it. Just from a pure human spaceflight perspective, when we start putting NASA astronauts on the other side of the Van Allen radiation belt in orbit around the moon, on the surface of the moon, those astronauts are in jeopardy of things like a solar flare hitting them or a coronal mass ejection, which would be, of course, even more devastating. And all of that radiation environment the astronauts are exposed to would be devastating. In fact, if you go back to Apollo 11, Neil Armstrong and Buzz Aldrin narrowly missed being hit with a solar flare that could have been devastating for their lives. So we didn't know what we didn't know back then. Now we have the ability to learn and predict. Thank you to you for your efforts to help us with that. But beyond that, I mean, when you think about the capabilities of our satellites in orbit, they become, in many cases, at risk from a coronal mass ejection or solar flares. So we need to be able to predict that. We need to be able to respond before, it's not a lot of lead time. We're talking about a matter of maybe 8 minutes or 10 minutes to be able to respond to something like that. But the consequences of being hit with a Carrington event, which was 100 and some years ago now, 140 years ago or so. But if that were to happen today, it would be far more devastating than even back then, because today we're so dependent on technology, and all that technology would be put at risk. So I think it's important for us to be able to predict and respond and defend our power grid and defend our critical infrastructure, and a lot of that infrastructure, including command and control in space, including GPS, which is important for a timing signal for a whole host of different capabilities here on Earth. We've got to be able to respond to that. And your bill, quite frankly, was right on point in helping us do that.
Right. Well, thank you for that response. I'm out of time, but if you look at the cost-benefit analysis, to cut the relatively small cost and the huge of the program and the cost to society if we don't have the warning is astronomical. So I appreciate your comments.
Literally astronomical.
Yeah, yes.
Astronomical. Yeah.